So, unveiling new artistic dimensions in calligraphic Arabic script with generative adversarial networks. So that's the presentation. And the author names are Arthur Shabandi, Philippe Pasquier, and Adam Tyndall. Who we have here is Philippe Pasquier. He is a scientific researcher, a multidisciplinary media artist, an educator, and a community builder. He is the director of the Meta Creation Lab for Creative AI and a professor at Simon Fraser University's School for Interactive Arts and Technology in Vancouver. There, he is pursuing a multidisciplinary research creation program focused on generative systems and applied AI for creative tasks. Philip, all yours.
Thank you, Rebecca, and hello, everyone. Yes, I come to you from Vancouver, and this is mostly the work of my PhD students, Arshia Soben. He started that work with Adam Tyndall when he was a master's student at OCAD in Toronto, and he since then joined the Meta Creation Lab. Unfortunately, and that's a problem for our community here in America, but also in Europe, for many, many conferences, he couldn't get a visa on time to come here, and that's becoming an increasingly important problem, something we should talk about more and make pressure so that the geopolitical tension of this world do not break our international, otherwise international academic communities. So with that, I'm going to bring Asha to you by playing a video of him presenting the work, and then I'll say a few quick words after that.
My name is Arshia Soben, and today I will present our paper, Unveiling New Artistic Dimensions in Calligraphic Arabic Script with Generative Adversarial Networks. This presentation will share a brief background and the motivation of this project, our dataset design and method, the training results, created artworks, and future directions. Arabic script is the world's second most used alphabetic writing system, shared between several languages and a key cultural element of over 20 countries. This script is renowned for its calligraphy art in various styles developed in different regions over time, and its influence continues today to contemporary works. In this paper, our focus is on the predominant calligraphy style of this script in Iran, which is called nastaliq. The structure of the Arabic script is inherently cursive, where letters connect to each other and take different positional forms. Some letters also share the same base form and are distinguished only by the number and the position of the dots. Despite its prevalence and cultural significance, technological advancements have failed to fully capture the unique visual features of calligraphic Arabic script. Notably, the movable type technology, which was mainly created for Latin script's block structure, struggled with the script's cursive nature and letter positioning, leading to a significant loss of visual complexities and dynamic forms. Generative AI has advanced significantly with generative adversarial networks, or GANs, introducing new artistic possibilities, and diffusion models and text-to-image generation further enhancing image creation capabilities. Although these advancements have sparked research on various scripts and artistic domains, calligraphic Arabic script remains underrepresented in both the research and the artistic explorations using generative AI. In our exploration, we utilize GANs for their unique affordances and their support of smaller datasets compared to diffusion-based systems. Due to a scarcity of large and consistently designed datasets focusing on calligraphy, we opt for creating a dataset for our GAN training. In this, we avoid scraping the web and presenting raw data to the network. Instead, we take an informed approach rooted in the traditional calligraphy practice to present the fundamental elements as data points in a regularized fashion. This is particularly important since the raw calligraphy data present an immense diversity of visual features, decorative elements, compositional forms, and other complexities and irregularities. We ground our dataset design in the traditional practice of mufradat, which is the calligraphic exercise of writing combinations of base letter forms to practice unique letter connections. Different approaches such as using archival material to extract data and commissioning a dataset were considered. However, both approaches pose significant practical challenges to achieve a large and regularized dataset. To overcome these challenges, we utilize a synthetic method as a feasible alternative. This method facilitates uniformity in color, stroke width, and style, and accommodates the creation of large amounts of regularized samples. In this method, we incorporate a calligraphy typeface in nastaliq style, combined with manual digital editing. The typeface used is Mirza typeface by the Iranian type designer Amir Mahdi Moslehi, which offers various possibilities for adding elongations and choosing alternative letter forms. Since the practice of mufradat is focused on the visual structure as opposed to forming meaningful words, we group letters with similar base forms to remove visual redundancies. With this reduced alphabet, we create a fully connected letter permutations of up to 4 letters. Later on, we also remove all the dots to keep the focus on the base letter forms. After creating the basic calligraphy forms, all possible elongations and alternative letter forms are also added for all the samples. This provides maximum possible feature diversity in the dataset. To ensure calligraphic correctness, this process is manually done by going through all samples and deciding on possible iterations to add, as well as removing incorrectly formed samples. Our final dataset, Nas4-60k, consists of almost 60,000 unique samples of up to 4-letter fully connected combinations. Since the permutations grow exponentially for higher number of letters, this dataset experiences an imbalance where single letters plus 2- and 3-letter combinations comprise less than 10% of the dataset. To resolve this issue, we augment the dataset by placing copies of letter combinations in different positions to create new data points. For this, we use different position grids with different augmentation coefficients to alter the position of the samples for each subset of the dataset. The result is an augmented dataset consisting of more than 125,000 data points with a more balanced sample distribution. For training, we choose NVIDIA's StyleGAN2 ADA network for its excellence in capturing meaningful visual features and user-friendly code. Using our datasets, we trained initially on Google Colab to fine-tune hyperparameters for training stability, and ultimately on more powerful cloud GPUs provided by Compute Canada. Our trained models accurately capture intricate calligraphic features, and the samples demonstrate proper letter connections. They also exhibit diversity in elongations and letter forms. As expected, the generated results of the model trained on our base dataset show a bias towards generating mostly 3- and 4-letter combinations. However, the generated samples from the model trained on the augmented dataset show a more balanced generation with more single letters and 2-letter combinations observed. An important feature of our trained models is the generation of samples with 5, 6, and even 7-letter combinations. Given that the datasets only include up to 4-letter combinations, this showcases the model's capability to generalize learned features and create novel combinations beyond training data. Our latent space interpolations smoothly morph between samples with interstitial forms, maintaining calligraphic integrity and allowing meaningful transitions between elongated and non-elongated forms. This characteristic allows access to a continuous calligraphic manifold, enabling calligraphy as moving images, which is a notably challenging task with traditional digital tools due to the complexity of codifying calligraphic features. Analyzing the latent space also reveals that subtle movements near sample points lead to notable alterations in calligraphic features, especially in the elongated parts. We harness the unleashed possibilities by the trained models in creating new artworks, taking inspiration from the compositional form of siyah-mashq. This art form is celebrated for bold forms and harmony, and while it highlights the dynamic and playful essence of calligraphic Arabic script, the constraints of traditional tools confines its expressions to mostly static forms. The continuous feature representation of our generative system introduces a new mode of creative expression, allowing access to a manifold of calligraphic features. By unveiling the interstitial spaces between letter forms, it enables the creation of dynamic compositions. This approach adds a dimension to static calligraphy and opens up new artistic possibilities for the digital creation of calligraphic Arabic script. We utilize this new expressive mode to create artworks that showcase a fluid representation of the script in its calligraphic form and unveil new possibilities based on traditional calligraphy principles. Our live performance, Reprising Elements, takes the possibilities further to a real-time interactive space. Using the real-time and audio-reactive features of the GAN-based visual synthesizer Autoloom, a 3-agent co-creative interactive performance is created where a real-time generative AI system, a calligrapher, and a sound artist act as autonomous agents while affecting each other in the process, seeking balance to create a siyah-mashq. Our latest work is a 9-piece collection titled Ensemble, showcasing dynamic compositional forms accompanied by AI-generated sonic textures.
And we'll be showing that that artwork at Ars Electronica later on this year. And so Arshia did this work, started at OCAD as a coder and finished working with Autoloom that he mentioned here at the end of the presentation. And I wanted to pitch that because this is a growing trend in generative AI. Instead of using big data and online models that have been trained and are ethically questionable, we are pushing an approach using small data and model crafting. And we've been developing at the Meta Creation Lab this open source synthesizer, which really empowered artists without any coding skills. And most painters, photographers, and graphists of this world do not code computers to train their own model, to manipulate their own model, so using their own data that they source, and to manipulate this model in a direct fashion, having access to all of the parameters available for those models, and export themselves stills or even moving images exploiting those models if they wish to do so. So I know that in this room some people might be interested in looking up either for teaching or for their own practice. This type of tool here is an example of direct manipulation of a model by a user. And so with that, I'm going to leave you. You can find us here at the lab. We'll be also at Mutex this year, presenting for the 25th anniversary in Montreal with the Society of Art and Technology and the Meta Creation Lab some work and some workshops around Autoloom, onboarding more and more artists. We'll be at Ars Electronica leading an exhibition with the Meta Creation Lab with 5 different pieces there. And then I'm also the chair of the steering committee for the AI music creativity community. And the conference this year will be just after Ars Electronica at Oxford University in the UK for those who are interested in generative music and AI and music. So with that, I want to thank all the fantastic funding bodies we enjoy in Canada, and thank you all for your attention.